Hi everyone, I'm Jesse.
And I'm Karissa.
And we're doing our senior project on inventory management systems at ABC Power Plant. So a little bit of background, it's a power plant who wants to reduce the costs of utilities to expand its customer base, and it specifically wants to do that by improving its warehousing operations efficiency. So our problem statement is officially to reduce the inventory management cost through reducing lost inventory, reducing inventory cycle counts, and reducing all the transportation that's associated with managing inventory. So with any big project, we want to start out with a review of what people have done in the past. We looked into a lot of facilities things, specifically with the layout. Shelving locations, there's a lot of operations research applications of designing 2D space to optimally use your warehouse for how you're going to put the shelves in there. Item locations, so where the items are on those shelves, put the items that are used the most closest to where you're picking them up, and put items that are used together a lot close to one another so that you can just pick them both up at the same time. And then order batching and routing, so how your people go around and get things, what items they try and pick up in one run, and what routes they follow to get there. Also, we looked at transportation technology, which is just what type of things people are riding around on, or if they're walking to the different locations in the inventory.
The next thing we looked at was the different ways of tracking items throughout the warehouse. Tracking items has a lot of benefits. Knowing where all your items are at any given time and how many you have of each one can reduce stockouts, and it helps you understand which items end up going missing and how and when that might happen. The most simple way to do this is to actually go around and have people do a physical inventory count. This is very inefficient and very inaccurate. There's a lot of human error involved in that. The next step up from that is barcode technology. We've all seen these before. UPC codes at grocery stores, items are scanned. A database logs the information about which item was taken out of the store when. It's a very similar warehouses would use barcodes in a very similar way. RFID, again, is the next step up from that. It's a much more expensive technology, but has the opportunity to store a lot more information, and it's a lot easier to track items efficiently. RFID scanners can pick up more than one item at once, and you don't actually need to have a line of sight to the item, so like a whole pallet full of items could go through a gate and it would pick up information about all of those items without actually having to see each one individually.
So then we looked a little bit into simulation. There's a lot of RFID supply chain examples of simulation, as well as just facility simulations. And simulation really helps evaluate the performance of all these things without actually implementing all the different scales.
And now we're going to go over our project plan. The first thing we're going to look at is the transportation technology, evaluating what they have currently and then deciding what the best solution for ABC Power Plant is, based on how much money it costs and which solution best fits their needs. The next thing we'll look at is their inventory tracking systems, again evaluating what they have now and which system best fits their needs. If we decide to use RFID, this will include finding the appropriate tags, either active or passive, and what brand, and there are many different kinds. And then the scale, do we want to tag everything at the item level or at the pallet level?
Okay, and then we'll look at the facilities design. This can kind of be done concurrently. First we'll look at potential process improvements, things like maybe cross-docking or just things that make the operation go more efficiently without changing the layout, and then we'll look at alternative layouts and things that can be done using some of the stuff we talked about in the lit review. Simulation will be a bigger part in the methodology because it'll be how we evaluate all of the potential changes before we actually implement that. And if you get some pretty advanced simulations, you can do a lot of fun statistical things with that, so I'm looking forward to all of that. And then the economics of all of it. So the transportation equipment costs money, and you have to keep up with the maintenance on that.
There are a lot of different costs involved in implementing an RFID system. The tags themselves cost money, the time it takes to place all the tags on all the items, getting all the readers set up, and along with the database to manage all this information.
And then with the facility, actually moving the stuff around, all the costs associated with that, and then the costs of not being able to use those areas while you're working on it, and of course, all the expected benefits from that. Here are some references with that. Pause now if you want to see those.